Hello and welcome to my video about Doubly linked list. In this video I'm going to be explaining Doubly linked list and let's jump right into it. So the first thing that I'm going to do is sort of draw out here what the structure of this video is going to be, and also just explain what the program is going to look like. So the first thing that we're going to have here is going to be a sort of what I'm going to call root right here, which is going to be sort of the beginning of our linked list. Sort of the head, it's going to be pointing to the beginning. Then we're going to have, just as an example, right now we are going to have 3 nodes right here. So this will be our first node, which is going to have a pointer to a previous node and a pointer to a next node. Then we're just going to have a variable here, which is going to be the information contained inside the node, which at this point we're just going to call number. And we are just going to have 3 of these nodes right here. So we're going to have number. We are going to have a pointer to a previous node, pointer to a next node, and the same thing with the third node right here. It's going to be previous, and it's going to be next, and just a number right here. So just for as an example right here, each node is going to contain a number, so it's going to be number 1, number 2, and number 3. So that's going to be the information that's going to be contained inside each node. So now what we're going to do is link the nodes. So previous node is going to point to the last node right here. Then the next part is going to point to the next node. So as you can see, the first node is going to be connected to the next node right here and to the previous, which is actually the last one, the last node in our linked list right here. Also, we're going to go ahead and connect this two right here. So the next pointer is going to point to the next node, and the previous pointer is going to point to the previous node. Same thing for this one right here. And because it's double linked list, we are going to point this node to the first node right here. So as you can see, all of them are connected to the next one and the previous one. And just for practice in this exercise, what we're also going to do is change where root is pointing. And we're going to do that as well. So let's say at this state right now, if you want to print what the double linked list looks like, is going to print 1, 2, and 3. So that will be sort of the original. So now what we're gonna do is rotate the how the numbers are printed. So what we're gonna do is, after the first rotation, what we wanna see is that 3, 1, 2 gets printed. So I'm just gonna call this R1, rotation 1. Then if you wanna rotate it again, so that will be our rotation 2. We want to see that 2, 3, 1. And if we rotate it one more time, so rotation number 3, this is gonna look like the beginning. 1, 2, 3. So this is what we want our program to do. So to accomplish that, what we really need to do is move where root is pointing to. So as you can see here, we have our node number 3 that after the first rotation is going to be the first number printed. So all that we really need to do is move root to point here instead of the first node, and we're going to remove this part right here. So as you can see, we are now at this stage right here, if we were going to print at this stage, what we're going to be printing is 3, then this node is going to point to the next one, which is going to be 1, and this node is going to point to the next one, which is going to be 2, and it's going to be printed in this order. So now if we want to move to this order, really simple, we just move what root is pointing to this node right here. So that's what we're going to do. We're just going to go ahead and remove what this is pointing to right now. Just remove that part and just point root right here. And that will be this result right here. So as you can see, we're gonna go from the beginning of our linked list, which is technically this node right here. We're gonna print number 2, then we're gonna look at what's next, and we are gonna move here and print number 3, then look what's next, move here and print number 1, and basically that will be this result right here. So now we're gonna go ahead and jump into the code. I'm gonna go ahead and remove this information right here and go back here. So the first thing that we need to do really is declare sort of the structure that's gonna form the node. So we need some type of integer here, since we're gonna have a number. That's gonna be our first information right there, and then we're gonna need a pointer to another node, which is gonna be sort of located in this. So we need this information. So we're gonna go ahead and jump into code and declare that. Okay, so the first thing right here, we're gonna go ahead and define a new structure. Type def struct, and we're just gonna go ahead and call it list. After we do that, we're just gonna go ahead and declare our int number, which is gonna be the information contained right here. Then we're gonna need pointers to other nodes. So in this case, since we're calling our structure list, is gonna be a pointer to a list that we are gonna go ahead and call previous, or just prev, and the same thing for the next right here. Ooh. Okay, and we're just gonna go ahead and put here the name of our structure. So after we do that, we already have this information right here. So the next thing that we're gonna do is just start our main function. So I'm gonna go ahead and say main, and we're gonna have a void right here, because we're not taking any arguments as for right now. So the first thing that we're gonna do is declare basically the root and assign it to null. So that's the first thing that we're going to do, and since it's going to be pointing to a node at some point, we're just gonna make a pointer to a typed list, and we're also going to just assign root to null. Right there. Also, since we're gonna be rotating where root is pointing to, we're gonna need some other variables. So we are going to also be using a variable that, oh, that might be confusing. Let's just change the name. So that's gonna be the size of the how many nodes are going to be. We're just gonna go ahead and use this variable. So this is gonna be the information for here, for this right here, and we're also going to say how many times we want to rotate to rotate the root. So we are going to be taking this information. We're just gonna go ahead and use a scanf, and I'm going to remove that, and we're gonna need the address. So we're gonna need size. Actually, I'm gonna be taking 3 of them, so I'm just gonna go ahead and put 3. So size, the address of number, and address of rotate right there. Rotate. So this is basically going to take these variables from the command line, and I think I need to include something, so just let me look at the library that I need to include. So I'm just gonna need to include the studio library here, and I'm just gonna put it right there. All right, so we are taking this information from the terminal, from the command line. The next thing that we're gonna do is actually calling the function that is gonna be creating the node. So I'm going to have a function that's called create node. So basically a function that will handle this information right here, and also handling the connections between nodes. The information that this is going to need is, of course, root, so it knows where to begin, and also is going to need the size to know how many nodes there are going to be. Actually, sorry, it's not size, it's number right there. And we actually need to have the address of the root, so we know where we are. Also, we are going to need to check for errors. So we're actually going to go ahead and put this inside an if statement. And if this if statement, so if this function does not return 0, or if this function returns 1, we're just going to go ahead and return 1 as well, meaning that there was some type of error. Now we are going to go ahead and define this here as well as a header. And since it's going to return a number, we're going to make a return integer. And this is going to be of type list. And we are having a double pointer to a root, and this is just an integer right here. And just don't forget the semicolon. Okay, so we are going to go ahead and jump into creating the node. So what we're going to go ahead and do here is define this information right here. Alright, so we're going to create the node. So the first thing that we need to do is allocate the space for this node right here. So you see this information needs to be allocated. The way that we're going to go ahead and allocate this is using malloc. But first things first, we're going to have another variable that I'm going to call node, since we're going to be creating another node, and we are going to allocate that memory for that node, and we're going to make it have a size of list, which is the size of our structure. I'm also going to check for errors, making sure that there was enough space in memory, otherwise this function will fail. So if node equals to no, we will return 1. That will be the return of our function if it fails to allocate enough space. After we do that, we are going to we're going to assign this information to our node. So right now what we just did was creating creating just this space right here without nothing inside. Now we're gonna go ahead and assign things to it because there's nothing inside it at this point right here. So what we're gonna do is actually assign things to it. So the first thing that we want to do is assign the number. So let's say we want to, the first number that comes through is number 1. So we're gonna have what node and then number. So this variable comes from here. So we're saying that the node number, which is defined here, is going to be this number right here that comes from our terminal. So that's going to be number. Now let's say just as an example, we had number 1. So that's gonna be what we just assigned here. We have number 1. So now what we're gonna do is also assign what the previous pointer is going to be pointing to, and in this case we're just going to make it point to null because we haven't created other nodes, and also we're going to be handling this in a little bit, and this is going to be next, and it's also going to be point to null. So the state of this right here is going to be next is pointing to null, and previous is pointing to null as well. Okay, so that is done. Now what we're gonna need to do is basically connect root to our first node right here, and I'm just gonna go ahead and connect this right here. So this is our node, and what we need to do, or what we want to do, is connect this right here, and basically root will not be null anymore, or will not be pointing to null anymore. So first things first, we're gonna go ahead and do that, and we do want to have this right here. So we are gonna check first. So we're gonna check if root equals to null, meaning that this is really the first time we're creating a node and we're gonna try to create this connection. Because if it was other times, and we'll see that in a little bit, root will not be pointing to null anymore. So, and it's actually what root is pointing to, which is pointing to null. So if root is pointing to null, then root, or whatever root is pointing to, is actually going to be node now. So we're going to go ahead and make this connection right here. We're going to go ahead and get rid of this null, because our program is not pointing to null anymore, or root is not pointing to null anymore in our program, and it's actually going to be pointing to this node right here. Okay. So that's the first thing that's going to happen. Then now what we're going to do is start connecting the other nodes, and this is going to be our next video. I'm going to be handling the other connections for the other nodes in this else statement, and we'll see you in the next video. Thank you.